MacMaths, let's do some maths today. Okay, MacMaths statistics here at AS level. So this is lesson 2B, and I'm going to look very quickly at estimated mean because you've done it before, and then I'm going to look at, from that I'm going to look at the estimated median. Not which group the median is in, that's GCSE. I'm looking at an estimate for the median from this, and that is an introduction to interpolation. It's effectively what we do when we're doing cumulative frequency, but from a table. So we're going to look at that. So that's new for A level, and I'm going to give a really important bit, a little talk to you on bandwidth. Okay, and this is really important. You've not had to think of it at GCSE, but you do have to think of it think about it at A level, and the context of the question changes, and the way that we treat the bandwidth or the class width will change. So really listen carefully when we go through that. Okay, so that's the lesson. So I'm going to start off with looking at a table here. Just made up some data, put it in. You're familiar to seeing continuous data treated like this. H, you probably guessed, stands for the height. Well, actually you don't need to guess because it's a centimetre. So let's say that in my greenhouse I grow pea plants, and I've measured my pea plants and I've put all that information into a table, and 3 of my pea plants are between 0 and 10 centimetres tall, and 7 of my pea plants are between 10 and 20 centimetres tall, etc. Put them into 4 groups. I extended the last group a little bit just to catch a couple that were quite tall, so I didn't have to create another group. Obviously I'm talking rubbish because I don't even grow pea plants, but there we go. And there's my data, and we're going to find the estimated mean. So very quickly, if we are to add up all of this data here, so 18, and just having a look because I've sort of done it over here. Yeah, sorry, I'm just getting sidetracked. If I add all of these up, the frequency comes to 34. That tells you that I've got 34 pea plants here that I've measured, 3 of which are between 0 and 10. And the reason that we call it the estimated mean, so that's the first thing we're doing. It's only grade C, isn't it, at GCSE? But for completeness, I might as well just quickly go through it. Because it's called the estimated mean because actually we don't know how tall these 3 pea plants are. We know that they're somewhere between 0 and 10 centimetres. So it's sensible to make an estimate for them and say that they're all 5 centimetres. Those 3 are 5 centimetres, the middle of the group. So we say we've got 3 at 5 centimetres, so we're going 5, add 5, add 5, add 7 of them at 15. So we're going 5, add 5, add 5, add 15, add 15, add 15, and so on. Okay, but a quick way of doing it is to go 5 times 3. That gives us those 15, the height of those 3 added together. So the estimated mean is going to be midpoint times frequency, 5 times 3, which is 15, 15 times 7, which is 105, 25 times 18, which is 450, and the midpoint, be careful, that one is 40 times 6, which is 240, and if we add those all up we get 810. And again, the mean, remember the symbol for the mean, is equal to the sum of xf, so x being the midpoint times the frequency, okay, divided by the sum of the frequencies, which of course is 810 divided by 34, which is 23, works out, as a rounded off to 1 decimal place, centimetres. I always tell my students at GCSE to do everything twice, so do it and do it again, because you're tapping lots of numbers. Write everything down carefully. It's dead easy because you're tapping so many buttons to do all of this. It's very easy to make a mistake, so do it twice to check you get the same answer. And then the last thing I always tell them to look at the context of the question. We're talking about pea plants here, and all those pea plants have a height of between 0 and 50 centimetres. There was no pea plant that was bigger than 50 centimetres, so between 0 and 50. Because we're finding an average, in this case the mean, the estimated mean, we're looking for An average is something that's in the middle. So a very rough estimate is to say, well, what's in the middle between 0 and 50? 25. So we're looking for an answer around about 25, which is what we've got there. Okay, so a quick check that your answer is sensible. Part B, this time is new. This bit is new, an estimate for the median. Now at GCSE, they ask you to. They don't ask you for this at the GCSE, an estimate for the median. They just ask you to find out, which group it's in. And because there's 34 pea plants, half of 34 is 17. So it's the 17th pea plant. Which group would that fall in? Well, cumulative frequency, there's 3 in there, another 7 in there, that up to there makes 10 pea plants. The next 18 are in that group, so up to 10 there, and then up to 10 add 18 is 28. Okay, so the 10th plant is the last one in this particular group. The next 18, taking us from the 10th to the 28th, are in this group here. So the median, if there's 34 plants, the median is the 17th plant. The 17th plant is in this group, in the group 20 to 30. That's what you would be asked for at GCSE. However, we're going to actually get an estimate for that. And the way that it works is this, is you look at you work out that position, so the 17th plant. We know it's in this group, so it's in the group, the class that starts with 20 and ends in 30. And we say that there are 18 pea plants in this class. So the assumption that we make here is that these 18 pea plants are all divided equally in this group. So in other words, if we divide this group up into 18 equal parts, okay, and they all have a little bit of that going on. So that's the 10th, the 11th, the 12th, the 13th, the 14th, and so on. Okay. So there we go. We divide that up. Now the class width is of course 10 between 20 and 30, and we've got to divide that up into 18 pieces. So we do 10 divided by 18. So that's the class width. And that is the frequency in group, F in group, oh dear, the frequency in the group, so 10. So that means that each one of these incrementations, oh, that's a good word, incrementations. Each one of these increments, is incrementations even a word? Increments, it might be increments, is 10/18 or 5/9 if we cancel it down. And actually the 17th, there's 10 in this, 10 up to here. The 17th, the middle one, is 7 then in this group, isn't it? Because 10 there and another 7. So 7 into this group. So we want 7 lots of those bits going in. So 10/18 times by 7. So we do that on our calculator. So here we go. Switch it on first of all. And we're going 10/18. Could have just put in 5/9, couldn't I? Okay, move that along. Times 7 of those bits gives us 35/9. Let's just press our, so 3.88, so let's call it 3.9. In other words, in here, 3.9 into that group. Okay, that's where our 17th position would be, 3.9, so not quite halfway in that group, because halfway would be 0.5, would be 5, wouldn't it? Okay, of the 10. So 3.9 in, but the group starts at 20. So that means that the median, an estimate for the median, would be at 20 plus this 3.9. So 23.9 centimetres. You can see very close to the mean, which is what we would expect. And again, if we had cumulative frequency and we went to the 17th and read it up across, okay, cumulative frequency, those curves that you draw do exactly the same thing. It should come across at 23.9. Cumulative frequency is interpolation, because it, that scale along the bottom divides the group up, the scale up the side divides the group up into that many pieces. Okay, so that's you're going to need that in the next lessons, whatever, interpolation. I'm going to go through it again with some other examples, but that's an introduction to it. There is a formula that the book uses for interpolation that you stick your numbers in and it finds the position for you. Don't you? It looks too complicated. I spent about 20 minutes working out what they were doing, but it's just so complicated. Do it this way. Draw out your little a diagram of your class width. Okay, think about how wide it is and then divide it up into that many pieces and do a little diagram. Okay, that's the way to do interpolation. Okay, and we're not just going to be using interpolation to find the median, the middle number. We're going to be using it to find the quartiles, you know, the upper quartile, the 25th percent along and the 75th percent. We can do that here. We just find 25% of 34 and find that sort of position and so on. Okay. All right, so I want to, before we finish and before you have a go at some of the questions, I want to talk about this class width because I'm going to pull it all together for you now, and this is a really sort of valuable lesson. Okay, this little next bit. So take note. Let's just stick with one of those class widths that we've got there, this 20 to 30. Okay, so this 20 to 30, when it looks like that, when it's drawn like that, you can see that that has a width, doesn't it? It has a width of 10. Okay, it has a width of 10, all right, and it starts at 20, or infinitely close to 20, starts at 20. So there's no mystery about that. But how could that be written another way in a question, this 20 to 30 group? Well, it could be written like that, and you've seen it written like that, 20 to 30. Now, if it's written like that, it's usually, but not always, okay, but it's usually talking about discrete data, okay, 20 to where it can only take certain values. I'll give you an example. Might be talking about people. So 20 to 30 people. It has a bandwidth of 10. 20 to 30 is a bandwidth of 10. Okay, and it starts at 20. If it's discrete data, same as this. Okay. However, it may be continuous data. And at A-level, you'll get questions where they might say, I'll give you an example of this. This is, so e.g., rounded to nearest minute. So it's just that they said, they had a group like this and they said, I know, 10 to 19, but it's rounded to the nearest minute, and then the next group is 20 to 30, say. Okay? And it would probably be 20 to 29 in that case, wouldn't it? But if it's been rounded to the nearest minute, they've done it like this instead of doing it like that. And what they're saying is that actually if it's 19, 0.4, then you're rounding down to 19. Okay, but if it's 19.5, you're rounding up to 20 minutes. Okay, so let's just say it's continuous data, but it's been rounded. If that is the case, then, okay, then the group starts, although it's 20 to 30, but the smallest it could have been was 19.5. So the group width is from 19.5, and of course it goes right the way up to 30.5, doesn't it? Because you can't say 30.4 because it could be 30.49 or 30.499, 30.499, that infinitely close to 30.5. So we say the limit's at 30.5. So when you're considering the bandwidth here, that you do need to for interpolation, when you're considering the bandwidth, if they're saying this is minutes rounded to the nearest minute, okay, then the bandwidth is actually from 19.5 to 30.5. So the width in that case would be 11. Okay, so the same group depending on what it's talking about. If it's talking about people, it's discrete, okay, or road accidents, it's discrete, okay, it would have a width of 10 and it starts at 20. If they're saying it's data that's been rounded to the nearest minute and it's time, okay, then now the bandwidth would be 11 and it starts at 19.5. Okay, so you have to interpret the question before you start doing interpolation, or and start dealing with things that involve the bandwidth of the class width, sorry. Then you have to actually put a layer of thought into it. And actually I wanted to show you this because there's another case. What happens if he told you that was people's age? Okay, if he told you it was ages 20 to 30-year-olds, of course, if you're 19 and 11 months and so many days, you're still classed as 19. So the width of this class, okay, right up until the day you turn 20, you're 19. So this starts from 20. But of course, when you turn 30, okay, you can be 30 in 6 months. You're still called 30. You're not called 31. You're not called 31 until you reach 31. So in other words, if they say that it's a group that has age, then the group is 11. It's a group width of 11 because it's going from 20 up to 31. So the width would be 11 in that case. Okay, so the same width as this one. However, where are we starting from? You're only 20 on your 20th birthdays, so it starts when you turn 20. Okay, and you're still 30 right up to 1 second before you're 31, so infinitely close to 31. So that, if they say this is to do with age, then the width of the class, the parameters of that particular class are different to this one and different to this one, aren't they? They're all three of those are different. So you have to be careful. You have to interpret the question and decide on what is sensible for the starting and the finishing point of that, because we need to start splitting these class widths up. Okay, straightforward when it's written in this form, because we just use 20 to 30, don't we? And the class width is just the biggest take away the smallest. It's not a problem, but there's a layer of thought that goes into statistics that you don't need in other branches of maths. Okay, and I wanted to make you aware of that. All right, okay. So that is, go and have a go at exercise 2B, and it's some questions on the estimated mean and so on, and I think it asks you, to compare some data, so just a little bit of practice from GCSE.